So today's topic is energy balance. It's chapter 7, page number 126 in your nutrition science textbook. Those who are joining late, please help them out with the page numbers. Those who have textbooks. Energy balance. So first of all, we'll go with the definition of what is kilocalorie. Like every now and then we do use that a person with this height and weight should have so much kilocalories, etc. So what exactly is this kilocalories? Okay, so typically 60 to 70% of your energy, body's energy, is used to release, and it is released as heat. Okay, you touch your body wherever you feel warmth, the end of your palms. Okay, the warmth in your breath. Okay, everything is because of the energy that is being generated within your body. Okay, and the remaining energy which is not produced as heat, which is not thermal, it is used up by your muscles for its contraction, relaxation, as well as at biological level, at your cellular processes, the biochemistry that takes place within your body. It also requires energy. So these are the three main areas where your energy expenditures take place within your body. Okay, so what is kilocalorie, kcal? Okay, so this is the metric that we use. Okay, either kilocalorie or kilojoules. Okay, usually in Indian metric system or everywhere else also, it's kilocalories that we use. Okay, so what is the definition of 1 kilocalorie? 1 kilocalorie is the amount of heat energy needed to raise 1 kg of water by 1 degree Celsius. For example, a water 1 kg of water. Okay, 1 kg of water is not exactly 1 liter. When you Google it, you will understand 1 kg of water is a little bit more than 1 liter. Okay, so 1 kg of water, if you want to change the temperature, whatever may be the temperature of the water, it could be at room temperature as well. Whatever is the present temperature of this 1 kg of water, you have to just rise it to 1 degree Celsius. Okay, for example, the temperature of the water is, let's say, 14 degrees Celsius. Okay, the amount of energy, heat energy required to change this 1 kg of water's temperature to 15 degrees Celsius, from 14 degrees Celsius to 15 degrees Celsius, just 1 degree raise in temperature. Okay, the amount of heat energy required to raise that amount of temperature, okay, that is called as, that heat energy, that amount of heat energy is called as 1 kilocalorie. Okay, so we have different calorimetries to determine how much of heat is being produced, okay, within your body because of metabolism, because of digestion. How much of heat is being produced in your body? There are different methods for that. One is your direct calorimetry and one is indirect calorimetry. Okay, we'll not go into the depths. We will just understand the basic difference between both these. Okay, what is indirect calorimetry and what is direct calorimetry? Okay, so direct calorimetry will only be able to identify how much heat is being produced. Okay, how much heat is being produced by your body because of these specific food. Okay, you had let's say a protein rich diet or a carbohydrate rich diet. Okay, every food has a thermogenic value to it. What is thermogenic value to the food? We will see that later. That topic is also coming up. Okay, so every food has an innate thermogenic quality to itself. Okay, and that food is supposed to take, whenever you take that specific food, it is supposed to interfere with your body's heat system. Okay, so how much heat is being produced in your body just to digest that food, in the process of digestion or as an after effect of taking that food, how much heat is being produced in your body? Okay, we have two methods of calculating that. One is direct and one is indirect calorimetry. What is the difference here between both these? Direct calorimetry will only estimate how much heat is produced. It will not give you any other information. But if you go for indirect calorimetry, it will also see how much heat is produced and what amount of gas exchange has took place. Okay, how much oxygen one has required, inhaled, how much carbon dioxide they have exhaled, the nitrogenous waste gas that they have produced. Okay, all these informations will be found using indirect calorimetry. But direct calorimetry will not give you all this information. Direct calorimetry will just give you the basic outline that this food is producing this much amount of heat within your body. Okay. So this is a bomb calorimeter, the image which you see here. Okay, it is used in laboratories. Okay, in laboratories like any food institutions. Okay, it's not used in every laboratory. Any laboratory which is linked to testing food. Okay, and producing food, manufacturers of food, testing food. Okay, these industries will use this kind of equipments. Bomb calorimeter is used. Bomb calorimeter is an example of direct calorimetry. Okay, it will only understand the amount of heat that is produced. Okay, here since it is tested outside the human body, you do not require information regarding oxygen exchange, carbon dioxide exchange. Okay, it's tested in a simulation. It is tested, a sample of food will be kept inside a chamber, and we will see to digest the sample of food how much heat, or how much heat is the sample of food producing. Okay, so that is bomb calorimeter. Then this is an example of an indirect calorimetry. Usually most of the athletes, okay, athletes who undergo or who are subjects to certain researches, athletes, sports person, or regular individuals who are subjects to various food related researches, they will be put on these kind of treadmills or cycling practices, okay, just to understand, after having this amount of food, okay, after having 100 gram of glucose or 200 gram of glucose, okay, how much energy the athletes can retain, how long can they perform. Okay, those students who have joined in sports nutrition courses as well, those who are giving the exams for sports nutrition as well, you must know the kind of researches which we do in sports nutrition, okay, which is mentioned in the sports nutrition textbook. So everywhere on those researches, the indirect calorimeter has been used. So this machine, the machine which you see, the setup that you see on the right side, the black and white image, okay, so this setup is used to understand how much of oxygen, okay, the athlete has inhaled, what is the gas exchange, okay, as well as the amount of heat that is produced in the athlete's body because of the food they have consumed recently. Okay, so these are the two tests because of which we can identify what is the actual heat generated by the body because of a food. Okay, so you just have to understand the difference between what is direct calorimetry, what is indirect calorimetry. So again, revising you the main difference. So what estimation will direct calorimetry give you? Put it in the chat box. What estimation can you find using direct calorimetry? Only heat, yes. And you, with the help of indirect calorimeter, what else you can find apart from heat? Yes, heat as well as gas exchange. Okay, why gas exchange is important? You all know the basic science that oxygen is required for any kind of oxidation. Okay, any kind of burning. Okay, oxygen is required, whether it is outside the human body or within the human body. You require oxygen to produce heat. Okay, so how much of oxygen is used up for metabolism rather than other expenditures in your body, we have to know that. Okay, so that's the purpose of using these test methods. Next, coming to physiological values of the food, physiological fuel value. Okay, so I guess we all know by the previous past students especially. Okay, 1 gram of protein can give you 4 kilocalories. Okay, carbohydrates, same, 1 gram of carbohydrates can give you 4 kilocalories. Fat, 1 gram of fat can give you 9 kilocalories. Okay, these are the kilocalories which this food macronutrients are supposed to produce within your body, within human body. Also taking into consideration the amount of protein, fat, or carbohydrates lost in digestion, because whatever you eat is not completely absorbed by your intestine. Some part of it you will lose it. Okay, lose it through feces, you lose it in the form of undigested food. Okay, so taking into consideration the losing aspect, we have these values. But if you in a simulation, okay, not within a human body, in a simulation, if you try to combust, 1 gram of protein in a simulation in a laboratory, what exact amount of kilocalories can you expect? Table 7.2. You can put in the chat box. Those who have the textbook, table 7.2, refer table 7.2. In a simulation outside the human body, if you try to combust protein, 1 gram of protein, yes, it is 5.65. 5.65. Outside a human body, protein can give you 5.65 kilocalories. Okay, within the human body, it gives you only 4 kilocalories estimated. That is also approximate. Okay, it's not that you can't just go by that number. In some human body, those who have a very low metabolism, okay, whose BMR, basal metabolic rate, is quite low, for them it will be much less. Okay, 1 gram of protein can give someone 5 kilocalories. The other person at the same time, same source of food, can give just 3 kilocalories. It also depends on the basal metabolism rate as well. Okay. So that's the physiological fuel value which you have to understand. Only the important parts from exam point of view I'm taking in this chapter. Others are too technical here. That is not required. Okay. Too much of research based paragraphs are given. That is not required. Only the inputs and the conclusions we are taking here. Next, coming to your energy expenditure. Okay. Total energy requirement, page 132. A pie chart is given. Okay, so the maximum amount of energy used up by your body is just to just for maintaining your basal metabolism rate. Okay, that is when you are not doing anything, even when you're sleeping, when you're not moving around, your body is still undergoing various functions. Okay, respiration, expiration, digestion, absorption. Okay, various involuntary activities that is supposed to keep you alive is taking place in your body. Okay, so those activities will require energy. Okay, so 60%. In your textbook they have given around 60 to 65. It's all approximately the same values. Okay, so about 60% of your energy expenditure is used up just to keep your internal organs functioning, involuntary. Okay, the things which you do not have the control over. For example, your heart keeps beating. Okay, heart also requires energy to keep beating. Your brain thinks. Okay, brain survives on glucose. Okay, the energy from glucose. So as your respiration, inhalation, exhalation. Okay, diaphragm moving up, diaphragm coming down, which helps in you to breathe in, breathe out. Okay, these all are involuntary movements which requires energy. So your BMR makes sure that you get this energy. Okay. Then you have your physical activity. If it is sedentary, this is a very basic generalization of an energy expenditure. Those who have a sedentary lifestyle or a moderately active lifestyle, they may have an energy expenditure pie chart, which is very close, very similar to this one you see right here. But those who have a very high and more than moderately active lifestyle, okay, your energy expenditure may have a bit more into physical activity. Okay, your energy expenditure, it could be used up by your physical activity up to 40% as well. Okay, it depends on your individual stamina as well as your day-to-day activities. So physical activity will require 32% of your energy produced by the body. And thermic effect of your body generates a heat energy to maintain that heat. Okay, your body has to be warm to be alive. Okay, to maintain that heat, 8% of the energy is used to maintain the heat in your body. Okay, your normal body temperature around 37 degrees Celsius, 36.5 to 37 degrees Celsius, to maintain that heat in your body, to maintain the heat of your body around that area, around this normal temperature of the body, you also require energy. Okay. So next, coming to the basal metabolic rate. This equation we have done in the previous section, okay? For previous past students, previous class, we have used this equation. What will make this equation into St. George and Mifflin? What additionally you have to do? Could you please put in the chat box? It will be a revision for you. This is the BMR equation, okay? Different for men and women. BMR equation, which you see on the slide, is different for men and women. What additionally you have to do here to make it a St. George and Mifflin equation for weight loss? There are two more steps that comes in. Yeah, you will multiply the answer that you get here. You will multiply with the physical activity level. Okay. It could be sedentary, active, moderately active, etc. And then you have to minus 500. 500 is just an average that we are considering. In some formulas, you will see the range is between 300 to 600. Okay. So 500 here is the average that we are considering to subtract from the answer. So that's when you will get the kilocalories one has to take to maintain a healthy weight, or for if you have a weight loss as a goal, that whatever answer you get after these two steps, that's the calories you have to maintain for months together. Later, you have to again change that calories based on your new weight. Okay, whatever is your reduced weight, you have to again switch up your calorie intake. You have to see, you have to understand what your BMR is based on. Are you at the risk of gaining weight or not? Okay, because if your BMR is low, we will also look into the factors that influence the BMR soon. Okay, if your BMR is low because of your lifestyle, okay, you are at the risk of getting overweight, then obesity, and along with that, you will get up a lot of cardiovascular diseases as well. So the risk of low BMR has to be identified. You should know your basal metabolic rate. Okay, based on that, you can make some lifestyle changes. If if your BMR is high, okay, it may be very difficult for you to maintain a healthy weight. You may keep losing your weight. Okay, though people who have a high BMR usually come under the underweight category. Okay, so they have to underweight also. What food changes, what lifestyle changes a person who is underweight has to do, we will take in tomorrow's class. Okay, continuation of the obesity chapter. So this equation, you can also use the softwares available online. Okay, nowadays you don't have to remember the formula as well, but it's better if you could remember this formula, it's better. Otherwise, whenever you Google it, calculate BMR, you will be taken to pages which already has this calculation. You just have to input the statistics, the weight, height, and age, and activity levels, etc. You will get the answer. Okay. You can't directly give the BMR because we have to sit face to face. We have to understand your lifestyle. Okay, what's your background in terms of family history, what digestive issues you have. Okay, so don't share that personal details here, because there are various factors that influence your BMR. We'll come to that later. Next, coming to physical activity ratio. From the physical activity ratio, you can find the PAL values as well. Okay, if you remember, if you come to page number 139, table 7.6, 139, table 7.6, that's the PAL values which we use in the St. George and Mifflin formula. Okay, step 2, whatever answer you get after calculating the BMR, multiply that by your physical activity level. If the client is heavy working client, the answer that you get from BMR, you have to multiply by 2.3. If the client is sedentary lifestyle one, multiply the BMR with 1.4. Okay, whatever answer you get, add 500 kilocalories. Sorry, if subtract 500 kilocalories if overweight, add 500 kilocalories if they are underweight. Okay, about underweight, how we have to calculate, we'll teach tomorrow. So physical activity ratio, these are the pre-designed ratio which is already researched on. Okay, the different kind of activities you usually tend to do at home, various people sleeping, TV, playing video games, okay, parlor things, music, school, washing, having a meal, slow walk, slow games, dancing, cycling, competition, fast games, fast walk, okay, how long, etc. You spent a minute by this. So these values have already been researched. You can find more activities as well. You can just Google about it. Physical activity ratio of dancing, physical activity ratio of Kathak, okay, physical activity ratio of racing, sprinting. Okay, you just add the activity name and just Google this term physical activity ratio. You will identify what ratio exactly you will get. Okay, per minute, this is the ratio that you will get, an energy cost of activity per minute divided by energy cost of BMR per minute. That's the formula. Okay, that's a formula. No need to by heart this formula, but the data is already available online. Okay, if at all there comes a time when you have to identify what kind of energy is being used up every minute if I do this particular activity. Okay, you can identify, does this activity come under sedentary, moderately active, etc. Okay, only for that purpose we use this physical activity ratio. Rarely in a dietitian's world they will use this, but just for your information, physical activity ratio is the per minute energy that you use up. Okay, per minute energy, every 1 minute when you are dancing or cycling, okay, how much energy has been taken up by your body just to do that physical activity. Okay, that idea is given by the physical activity ratio. Okay, so the formula to physical activity ratio is, numerator is energy cost of an activity per minute divided by energy cost of BMR per minute. Okay, so using this numerator and denominator, food scientists and food enthusiasts have come up with the PAR ratio. Okay, so the list, this is just a list which I took from a random online source. Okay, if you look for physical activity ratio of various activities, you will get n number of softwares and number of data on it. Okay, whichever data you feel going with, you can select that web page and use it for your reference. Okay, but rarely you will come across a need to use this physical activity ratio, because as soon as the client will start telling you, I usually don't take part in any exercise, I have a very sedentary lifestyle, okay, I don't even participate in walking for half an hour. Okay, so by that you can understand they have a very sedentary lifestyle. Okay, if the client says that I walk for 1 hour, okay, I brisk walk for 1 hour, it's a moderately active lifestyle. Okay, just by asking them what exactly you do, what physical activities you do on a daily basis, based on the answers that they give, you will have an idea, is it sedentary, moderately active, active per se. Okay, so the physical activity level given here, it is slightly different from the ones that is given in your textbook, but both can be used. Okay, so the sedentary lifestyle, your PL activity is from 1 to 1.39, which is almost equal to 1.40, which is given in your textbook. Okay, so if you are dealing with an Indian client, okay, please go by the ICMR. Okay, ICMR 2020, the column that is given on table 7.6. Table 7.6, you see sedentary, moderate, and heavy work. Just beside that, you see ICMR 2020. Follow that. Okay, if you're dealing with Indian clients, just follow what Indian Council of Medical Research is giving you the data on. Okay, just follow ICMR 2020. If you are going to practice somewhere else in USA, UK, or or elsewhere, then you can go for what FAO, Food and Agricultural Organization, WHO, and UNU has suggested. Okay. But in Indian audience, dealing with Indian audience, just go for what ICMR has given. So don't use any other formula. Just use when you are using the St. George and Mifflin formula, just use the formula based on what the ICMR has given for physical activity. Okay. And in ICMR, you just have three category. Either you have a sedentary lifestyle, you have a moderately active lifestyle, or a heavy work lifestyle. Athletes, sports personalities, they all come under the heavy work. Labor workers, okay, daily wage workers, labor workers, they also come under the heavy work category. Next, coming to the thermic effect of food. So, generally speaking, thermic effect of food is the food which has higher protein value. Okay, the food that has higher protein value, your body will use a lot of energy to digest that food. Okay, the body will use up lots of energy to break it down, digest it, absorb it, metabolize it. Okay, so what is the end result here? Your body is producing energy, okay, and it is being used up, the energy is being used up to digest, metabolize and absorb protein. So what kind of result would you will you appreciate here? What kind of results are you looking for when you have a protein rich diet in terms of weight management? Your body's maximum energy is being consumed up just for the digestion, metabolism and absorption of proteins. Yes, weight loss. This is the reason why people who aim for a weight loss, okay, we guide them to reduce their fat and reduce their carb, because we want to direct the natural basal metabolism that they have. Okay, the your BMR that they have, you want to level up their BMR game. Okay, and how will you level up the BMR? By increasing the protein content. Okay, that's when a high BMR rate will be achieved. So even after few weeks, if they indulge in certain cheat diet, okay, they indulge in a carbohydrate rich diet, it will not affect their weight gain, because they have increased their BMR by introducing more protein in their diet. Okay, the body has started utilizing maximum energy. Okay, if their BMR was earlier just 40 or 50, okay, now as soon as they have introduced more protein, the body is starting to fuel up a lot more energy into digestion and metabolism. Okay, so earlier the BMR maybe just 30 to 40% energy was used in BMR. Now it is 60 to 70 or more. Okay, so the person has leveled up their BMR gain. So even tomorrow, if they indulge in a bit more of carbohydrate rich diet, a fat rich diet, they already have a high BMR. Okay, so because of that, the high carb diet and fat diet will also be getting metabolized sooner. Okay, so that's how thermic effect of food, the information from the thermic effect of food is valuable. Okay, so from the textbook on page number 140 or 142, from the examples given, some students do not have the textbook yet. Okay, new students, so help them out, give some examples of naturally high thermic food given in your textbook, page number 142. Meat, dairy products, caffeine, dairy products, caffeine, beef. Okay, plant-based foods are not given here. Red meat, caffeine and dairy products are given. Okay, So these are good sources of not just protein-rich food. Okay, caffeine is not protein-rich, but the other two, dairy products and red meat, they are. Okay, so they are naturally thermogenic food, which is supposed to increase your basal metabolic rate. Okay, so if you are into building more lean muscle, okay, you want the weight gain. Okay, you want a healthy weight gain, but you do not want that weight gain coming from fats. You want the weight gain from muscles, lean muscles. Okay, so this is where you have to focus more on. Okay, red meats, or if you are a vegetarian, you can go for the plant-based protein, which has a high DIAS score. Okay, DIAS score, what it is, etc. For new students, we will when the protein chapter will come up, we'll teach you in detail. Okay, so food that has naturally high DIAS score, plant-based food, go for that. Okay, pulses and lentils, they have protein. Okay, they have protein, but in terms of bioavailability, is the protein from lentils and pulses enough? Based on the bioavailability of proteins, or let's say amino acids, from lentils and pulses, is it enough for human body? It's not. Okay, so you have to refer the DIAS score for this. Okay, or you can just Google it as well. DIAS score for vegans or vegetarians. Okay, you will get the list of exceptionally good protein, okay, which can work as good as egg protein or red meat protein for vegetarians. Okay, options are there. See, nuts we can't say as protein rich because nuts have a fat quotient as well. Okay, nuts have protein, no doubt, but they also come with a lot of fat. See, requiring supplements or not requiring supplements in today's day and age, it's out there for debate. Okay, like if I pose a question, the food that you were getting 20 years back, the nutritive value of the food that you were getting 20 years back, is it the same? Would you consider today's food, agricultural food, at the same level from the nutritional aspect? No, right? So for today, if you want to live a micro deficiency free healthy life, to an extent you may have to incorporate supplements as well. Okay, you can incorporate plant-based or animal-based supplements, but in today's day and age, if you go and see where you are sourcing your vegetables, fruits, your pulses and lentils from, okay, if you do dig deeper and search their bioavailability of the nutrients these pulses or vegetables are supposed to claim, okay, you are not getting even half of it. Okay, you are not getting even half of it. So based on this situation, nutritional supplements, yes, it is a go-to, but they also have a drawback. Nutritional supplements, they may not suit everyone. There are high chances of overdosing, toxicity. Okay, and some cases, if you are unaware of allergies, unknown allergies, that could trigger some life-threatening conditions as well. Okay, so there are certain drawbacks to nutritional supplements also cost factor. Okay, on a monthly basis or a daily basis, if a family of 4 has to depend on nutritional supplements, it comes from a good quality, from a good brand, from a good quality, well researched ones, etc. You will have to pump up some money for that as well. Okay, so there are a lot of drawbacks, but speaking about the truth, based on the bioavailability, the food that you eat is just not enough to an extent, until or unless you have a small farm of yourself. Okay, you are growing your vegetables and fruits, taking care of the soil well. Okay, adding nutrients into the soil, fertilizers into the soil, natural fertilizers into the soil, etc. Only that's the way out. Okay. Yeah, growing methods nowadays, it is most of the food that you eat is genetically engineered. Most of the vegetables that you eat, seeds are becoming less and less day by day. if you start to notice the vegetables, the seed number of seed the vegetables used to have, it is getting less and less. Means what? These vegetables, the seedlings are genetically engineered. Okay, so definitely it has a major effect on the nutritional value as well. Okay. See, for vegetarian people, the best option for protein is go for sprouts. Take any pulses, lentils, sprout them. Okay. You can prepare tofu at home as well. From the soya milk, you can make soya milk at home. You can make tofu at home if you have the time and resources for it. Okay. But otherwise, the easiest way out is go for sprouts. Okay, that's the best option. Next is resting energy expenditure. Again, your BMR. So, whatever food or oxygen a person takes, okay, it is utilized first of all, it will be utilized by your vital organs. Okay, all your vital organs will utilize the energy from it. Every vital organs has their own structural and functional unit. Okay, when it comes to small intestine, it is enterocyte. Okay, cardiac muscles in the heart, adipose cells in the adipose tissue, neurons for your central nervous system. Okay, blood, it's a fluid connective tissue, so blood cells, RBCs, WBCs, platelets. Okay, so every vital part of your body has their own structural and functional unit. So at the cellular level also, the energy from the food, the nutrition from the food, as well as the oxygen you breathe in is getting utilized. Okay, and from there, in the mitochondria, the last image that this you see here, this is happening within your cell. This is the mitochondria. Okay, and what is the mitochondria known for? In the chat box, I guess people who are from the commerce background will also know this answer. What is mitochondria known for? It is the powerhouse of the cells, means it generates energy. Okay, it takes ATP and it gives out ADP. Okay, and in the form of making ATP into ADP. Okay, when one phosphate ion from the ATP is getting split, okay, it releases carbon dioxide, heat, water, nitrogen. Okay, and this heat is again further utilized by your body to maintain the body functions intact. Carbon dioxide will be exhaled from the body. Nitrogen will leave your body through urea, through your uric acid and urea. Okay, water will be consumed up within the cells as well. In case of dehydration, water released will be consumed by the cells as well. Okay, excess water will be thrown out of your body by the through the kidneys as well as your intestine. Okay, the heat generated when the adenosine triphosphate, ATP means adenosine triphosphate. Okay, it becomes adenosine diphosphate, from tri to di. Okay, from 3 phosphate ions to 2 phosphate ions. When the splitting of phosphate ion takes place, that's when energy is released. Energy, or you can call it as heat, is being released. Okay, so all these things are happening without you voluntarily, like even if you're sleeping, even if you do nothing. Okay, ATP is being produced. Okay, your body is generating heat. You are inhaling, exhaling. Body is generating the metabolic water, the H2O you see here, the water. Okay, it is called the metabolic water, the water that came after metabolism, the water which is a byproduct of the body's metabolism, that is the metabolic water. Okay, so not just the water you drink, okay, but it's also the water that the body produces as a byproduct of metabolism. Okay, so these are the different levels where your basal metabolic heat is being produced in adults, not just in adults but even in all age group. This is the same theme. Now coming to the factors which will affect this resting energy expenditure. First is your body composition. Like, for example, people who are lean or people who are obese. Okay, who will have a better basal metabolic rate? Is people who have a lean body composition. Okay, they will have a higher metabolic rate. So people who have more fat in them, okay, more fat in their body, it also affects the way how vital organs are undergoing their heat energy production. Okay, so if you are obese or overweight, the way how the vital organs are supposed to create the heat energy, that's not happening at the same level as a person who is leaner. Okay, that's the reason why. And mostly because the adipose tissue is much more. Adipose tissue is the fat collecting cells. Okay, adipose cells is the fat collecting cells in one's body, which is higher in amount in obese people. That will prevent the vital organs in generating the heat. The adipose cells in turn that will try to generate maximum heat, so that the vital organs, that they will not try to produce much heat. So naturally the BMR, because of vital organs not producing the heat, will go down. Okay, whereas a person who is lean, they have much less amount of adipose cells in their body, which will not interfere with the heat production of the vital organs. Okay, that's why their BMR stays high. So that's the reason how body composition may affect the BMR. Next is gender. So who has a better BMR, basal metabolic rate, men or women? Yes, men. Again, what would be the reason here? Why men have a higher BMR as compared to women? Yes, men have naturally more lean mass. Okay, lean muscle mass. Women naturally have more adipose cells. Okay, why women have more adipose cells? Because these fat cells will be used for hormonal production as well as supporting the female body for reproductive age, for preparing for reproductive age, as well as during pregnancy and lactation. Higher the amount of adipose cells present in your body, the child is better, the child is able to achieve better growth and development because of the mother's high amount of adipose tissue. Okay, it doesn't mean a woman has to become overweight or obese, because that will lead to complications in pregnancy. Okay, but in generally speaking, if you see the fat mass in women is much higher than men, it's just for the reproductive health, to maintain the reproductive health. Okay, so that's the reason why uh, how adipose tissue, here again, how the number of adipose tissue, the amount of adipose tissue will affect the BMR rate. The less amount of adipose tissue you have in your body, more will be your BMR. Then coming to age, okay, again, kids in childhood, your BMR is quite high, you are highly physically active. Okay, and take part in extracurricular activities. Even in teenagers have this growth spurt. Okay, to keep up with the body's growth requirement, development requirement, BMR naturally stays high. Okay, but once you have reached adulthood, midlife, okay, slowly when the age increases in, your BMR falls down. Okay, so yeah, younger the age, higher will be the BMR. As you get older, your BMR drops down. Body size and surface area, again, a major determinant here. So again, as mentioned in the textbook, if your body surface increases, okay, there is a lot of heat loss that can take place from your skin. Okay, the more is your body surface area, like in terms of length, breadth, and width, etc., more will be the skin surface area. And when you sweat, when a person who have a larger body surface area and a person who has a very lean body surface area, they are exposed to the same amount of climate. Okay, they are in the same place, exposed to the same amount of heat and climatic changes. Naturally, the person who has a bigger surface area, body surface area, will sweat more. Okay, so the heat loss from the body is much more in a person who has a greater body surface area as compared to a person who has a leaner surface area. So definitely that will also affect your BMR. Okay, when the body knows that there is going to be a lot of heat loss, it anticipates it, and the body tries to keep the BMR high. Okay, the body tries to keep the BMR high. So a tall or thin person who has a great surface area than an individual who has the same weight but who is like short and fat. Okay, so the person who is taller and who is thin will have a higher basal metabolic rate, because the person who is in the same weight category but short and is much more fat, they are losing a lot of heat energy through sweat, and the body is in a cooler state. When the body is in a cooler state, the BMR will not be high. Okay, the body has to continuously emit heat, which is a sign that okay, your BMR is high, your body is generating a lot of heat. Definitely, you have a high BMR. Then sleep. During sleeping hours, your basal metabolic rate is 10% lower than when you are awake. Okay, when you sleep, the BMR falls down. Then body temperature, as soon as your body temperature moves beyond 35 degrees Celsius, for example, whenever you are sick, you have a fever, okay, your BMR is quite high. Your body is continuously breaking down its own storage of macronutrients to require to meet its energy requirements. Okay, so that's the reason why whenever a person is sick or who a person has fever, we give them high carbohydrate diet. Okay, fat is avoided because the body is not in a capacity to spend time and resources to metabolize and digest fat. Okay, so high carbohydrate diet is preferred here, so that an instant shot of glucose and instantly the glycogen stores that has been replenished by the body, it could be filled up. Okay, then endocrine glands, hormones like thyrosin that is secreted by your thyroid gland. Okay, it's a powerful stimulator of metabolism. So those who have thyroid issues, hypothyroidism, people who do not have enough amount of secretion of this thyroxine hormone, naturally their metabolism rate will fall down, and that's the reason why people who have thyroid issues have a high chance, hypothyroidism have a higher chance of being obese or overweight. Okay, because of the absence of, or not absence, very very less secretion of thyroxine hormone, the metabolism is not able to stay up. And in pregnancy, your BMR increases about 5% during the first and second trimester. And then in your last trimester, the BMR increases by 12%. Okay. This is just to keep in check that the weight gain of the pregnancy is not leading to obesity or other heart-related issues. Okay, just to keep that in check. This is the body's natural system that has been instilled. Okay, as soon as the woman reaches her third trimester, that is the 7th, 8th, and 9th month of pregnancy, the BMR will also increase. Okay, by 12%. In the first two trimester, it is just 5% increase in the BMR. Then is this your state of nutrition? If you go into a crash diet like fasting, or suddenly for 10 days weight loss challenge, 7-day weight loss challenge, okay, if you go into such fads, what is going to happen to your BMR? Can you answer in the chat box? when you jump into some crash diets. It will definitely decrease, drastically decrease. Okay, it will not jump high, it will decrease. Okay, if you go into crash diet, etc., your BMR will decrease by 30 to 40%. Then after your diet program is done and you suddenly start overeating or indulging normally in food, okay, what will happen then? Your BMR has crashed down. Okay, it has come down 30 to 40% because of your crash diet. Now suddenly you have uh, gone back to your previous way of diet, normal diet, not even overeating. You're just normally having a balanced diet. What will happen to your body as a repercussion? Yes, you will definitely have rapid weight gain. Rapid weight gain. Okay, because here the food that was not giving you weight gain earlier. Okay, after you went into a crash diet, your BMR fell down. Now when you go switch back to your previous routine, that will also affect your body. You will have immediately, you will face weight gain, which is very difficult to lose back again, because of the result of low BMR, okay, and high calorie. Then we have environmental temperature, that is seasons like summers. Okay, summers you will naturally have high BMR, and seasons like monsoons and winters, when it's a cold season out there, your BMR will be low. So it's easier for you to lose weight during summer months and gain weight during winters. Then smoking, uh, people who are chain smokers or habitual smokers, when they stop smoking, they have a tendency to gain weight, because smoking is known to increase your BMR, and that is the reason why a lot of models, etc., and people who are in the entertainment industry, they keep smoking, not just because they're addicted to it, but they know it's an easier way to manage their weight. Okay, because in the film industry, in the entertainment industry, the way how you look, the leaner you look, you are more preferred for various roles. Okay, so instead of dieting, etc., they may find an easy way out to smoke, and using because of smoke, because of nicotine in this cigarettes, it is able to increase your BMR by 10%. Okay, so you can indulge in good food as well as not gain weight. So that's the strategy most of the models, male and female models as well, they use. Okay, then genetics, some people are naturally blessed with high BMR. Whatever they eat, how much ever they eat, they don't gain weight. Okay, some have, by genetically they have a low BMR. Then your psychological state, if you are anxious, if you are under stress, your BMR will increase. Okay, when you are depressed, etc., your BMI comes down. Okay, so when you get panic attacks, anxiety attacks, okay, when you are in a very stressful situation, your BMR increases, and that's the reason why you feel hungry as well. Okay, you overeat, you feel hungry, because your body is in a catabolic state when you are stressed, anxious. Okay, your body is in a catabolic state, your body is breaking down its own macronutrient stores to feed up the energy required by caused by the stress. Okay, so BMR increases in stressful activities, in a stressful state. BMR decreases when you are in a depressed state. Then certain drugs like nicotine, caffeine, they may increase your BMR, and beta blockers, etc., calcium blockers, beta blockers, they are used to treat hypertension. Okay, that is supposed to that will cause a decrease in your BMR. So these are the effects of drugs that can have on your BMR. And disease processes, like when you are fever, when you have cancer, okay, and when you have been affected by burns, okay, moderate to severe burns, again the BMR will be high. Fever, as I have mentioned earlier, body goes into a state of catabolism. So during fever, high carbohydrate diet is suggested. Liquidy, fluid, high carbohydrate diet is suggested. People who have cancers, tumors, they also lose a lot of weight. So people who are suffering from tuberculosis, okay, losing the muscles, wasting of muscles takes place. So that also affects their BMI.